Okay, guys, this is 10.1 graphs of square root functions. So I want to talk about that, then hopefully give you some ideas. This is what we're talking about with a graphing calculator and without a graphing calculator. So without a graphing calculator, you have to basically make values in a table, as you can see right here. And the values you want to use are perfect square roots. That's the best way to do those. Non-perfect square roots are going to get approximate values, but they still work. So a square root function contains the square root of a variable. Square root functions are a type of radical function. The expression under the radical sign is called the radicand. For a square root to be a real number, the radicand cannot be negative. So you can't have negative square roots, as you know this. Values that make the radicand negative are not included in the domain. Domain meaning the x values. Remember, the domain is the x values, the range are the y values. So here is the parent function of a square root function. Okay, this is called the parent function of the square root function. Okay, so you can see values. If I put 0 in for x, I'm going to get 0, 0, which is this point right here. Now, if I put 3 in for x, I'm going to get the square root of 3. So that would not be a good choice of an x value. So let's put 1 in. If I put 1 in, the square root of 1 is 1. So I'd have 1 to the right, 1 up. And then the next perfect square root is the square root of 4. So if I put 4 in for x, I get 2. Square root of 4 would be 2. So the value, the coordinate would be 1, 2, 3, 4, and up to. There is the parent function always. 0, 0, 1, 1, 4, 2. Okay? So the domain and range, what is the domain? Domain is the x coordinates. So everything's starting from here to the right. Remember, domain goes right or left. So right or left, that's the domain. The range goes up or down. Okay? So the range goes up or down. Domain right or left. In this case, we're not going to go left because there isn't a negative x, because if x is negative, you can't have a square root of a negative number. So you're not going to have anything over there to the left. So let's talk about if I have the square root function here in my calculator. If I just hit zoom 6 or 6 standard window, I get this. I see that, but it goes out to 10 and up 10, left 10, down. I want to zoom in into this one. This one goes -2 to 5 and -2 to 5. So if I change that window to -2, 5 going by ones, -2, -2 and 5 going by ones, I get pretty much that same window. Okay? So we need to learn how to change the window. So let's do example 1. And then 2, 3, 4, and then we'll talk about what's happening here. So example 2, I'm going to slide this down a little bit so we can compare. So I'm going to always keep the parent function in there. Okay? Now example 2 says f of x equals 2 times the square root of x. State the domain and range. So 2 times that. So what do you think that's going to happen? Well, it's 2 times the values of whatever you get here. If you put 0, 1, 2, 3. But once again, what I say, put in values of x. I'll try to zoom in a little bit. Put in values of x, that would make it easier. So I'm going to try to move this a little bit. I can't. It's not there. That's probably the best I'm going to get. Hopefully that's in clear. So what I'm looking for are values for x. 0, 0, that would be 0, 0. If I put 1 in for x, I get 2 times the square root of 1, which is 2 times 2. So I get the point 1, 2. So that works. 1, 1 for the parent function, 1, 2 for this function. Now 2, if I go 2 to the right, now I'm going to get an approximate value for both of these. If I go 3 to the right, 1, 2, 3 to the right, I'm getting approximate values again. But if I go 4 to the right, that's because x is 4, so that's going to be the square root of 2. 2 times 2 is 4, so I'm going to have 4, 2 for the parent function, 4, 4 for the other function, the 2 times the square root of x. Now, if I put those both in my y equals, I would have the square root of x, and I'd have 2 square root of x for my next graph. And now when I hit graph, you can see that that function it goes up twice. So if I look at the points, I have 0, 0, I have 1, 1, and 1, 3, 1, 1, and 1, 2. I'm sorry. 1, 1, and 1, 2, because it's 2 times 1. And then I have 2, 2. I'm sorry, 4, 2 for the parent function, and 4, 4 for the 2 square roots of x function. So if I look at the table, that's exactly what I see. 0, 0 for both. And then I come down here, where's the next perfect square? Square root of 1 is 1. So I'd have 1, 1, and then 1, 2. And then the next square root is square root of 4. So square root of 4, I get 4, 2 for the parent function, 4, 4 for this function. Okay, let's move on to the next one. So basically you're making values of a table or in your graphing calculator, whichever one you can use. Okay, now let's go down to the next question. Let's slide it over so I have room. This next one says, what if we have y equals, or f of x equals -3 times the square root of x? Again, we want the square root of x to be perfect squares to get nice numbers. So I'm going to go in here, y equals, and I'm going to change this to -3. Now remember, you can second insert a negative and then delete that, or put a 3 right there, and then delete by hitting just the delete key, which is right here. And then you have -3, or type it over. So you got -3x. Now if I hit graph, here's what happens. There's my parent function, and here comes the other graph. Now what did it do? It reflected over the x-axis and then got more steep, okay? So it looks like this. But I want to go down farther. So do you see how this goes down farther? So the y goes 1, 2, 3, 4, 5, 6, about 7. So my y-axis goes down 7. So y minimum is -7, like that. And now when I hit graph, you can see the parent function, and now you can see the function y equals -3 square root of x. Remember, you're always going to have to put values in to graph these points. So 0, 0, and then 1, -1, 2, 3, because the square root of 1 is 1. 1 times -3 is -3, so you'd have the point 1, -3. Then you want to have another perfect square root, which would be the square root of 4. The square root of 4 is 2. 2 times -3 is -6, so your value would be 4, -6 down here. Those are the values you want to choose. Let me show you what I mean by that. In order to graph this, I would choose 0, 0, put a 0 in there, I'd get 0. I'd put a 1 in, I'd get 1, square root of 1 is 1, times -3 is -3, so I get the point 1, -3, which is this point. Now I wouldn't choose any of these are not going to be perfect squares. The next x would be 4, because the square root of 4 is 2. So I'm going to go 4 to the right, 1, 2, 3, 4. Then the square root of 4 is 2. 2 times -3 is -6. So 1, 2, 3, 4, 5, 6. Those are the 3 points I would choose. I wouldn't even choose that one. That's in the middle. I would choose 1, 2, those 3 points to graph that function. And that's how you would do that. See how they get 0, 0, 1, -3, 4, -6. I would not choose this point. Okay? So notice that the graph is in the 4th quadrant. It is obtained by stretching the graph y equals square root of x vertically, because it's -3, and then reflecting it over the x-axis. Your domain is x greater than or equal to 0. So all your values from here to the right, and your range is all the values less than or equal to or down from 0 down. So y less than or equal to 0. Over here, the domain was x is greater than or equal to 0, and the y values from here up, y is greater than or equal to 0 would be your range. Okay, domain right or left, range up or down. Okay, all right, example 3. So I'm going on 9 minutes here, so I'm going to continue. Let's see if we can talk about the example 3 here. So example 3 says, compare the parent graph, state the domain and range. What if you have the square root of x, the domain, or the parent function plus 1, with the plus 1 on the outside of the square root, rather than the -2 inside the square root? What happens to that function? Well, in this case, what happens is you take the parent function and you just move up 1. And that's what happens there. So you can still get the value 0, 0, put 0 in, you get 1. put 1 in, you get the square root of 1 is 1, plus 1 is 2. You put square root, and you're using, remember, x's, you want square roots. You would not use this right there. It does not help you. So 9, 4, square root of 9 is 3, plus 1 is 4. So you would graph these 4 points here, over here on this graph to get this graph. Okay, and you can see that because the plus 1 is on the outside of the parent function, it moves up. Okay, we're talking kind of like what the x squared function does. Now this one, in this case, when you have -2 underneath the square root paired with the x value, if you do that, if you, let's say you put 2, let's put 0 in, you wouldn't work, it wouldn't work out, because 0 minus 2 is -2. Square root of a negative number doesn't work. That's why there's no 0 here. So what happens? You put 2 in, you get 0, so you get to 0.20. It moves to the right too. So x minus, we call this h, will move the parent function to the right 2 places. That's what it says here. This is a horizontal translation 2 units to the right of the parent function. The domain is from 2 to the right. Remember, you start here and you go to the right, so your domain is x greater than or equal to 2. Your range is still from here up. Okay, so y greater than or equal to 0. You start at 0 and you go up. Okay, so that moved it to the right, or up, I'm sorry. This moved it to the right too. All right, so with that said, we have now a kind of a rule that we can now follow. Let me see if I can zoom this in. I'm going to stop this video. It's around 11 minutes. Well, no, I'm going to keep it going because we got to get this done. So value of a is negative in the quadratic ax squared. The graph of the function is reflected over the x-axis whenever this a is negative. So if it's positive, it's just going to get bigger, grow faster. If it's negative, it's reflected over the x-axis. This h moves the figure, translates the figure either right or left, depending on the h. This k moves the figure up or down. Okay, that's what all this says. So here's another real-life example. The Golden Gate Bridge is 67 meters above the water. The velocity v of a freely falling object that has fallen h meters is given by the velocity equals the square root of 2gh. So where g is the constant, 9.8, okay, and then we substitute these in right here. The square root of 2 times 9.8 times the height, 67, and we'd get the square root of that, which is 36.2. This means the velocity of the object is about 36.2 meters per second after dropping 67 meters. And this would be your graph if you would substitute that in, if you were to put that in for that. That's what it would look like. Okay, example 5. What happens to this graph if we have a -2? Well, it's reflected over, remember, here is the parent function. Starts here at 0, 0, 1, 1, and then 4, 1, 2, 3, 4, 2. There's your parent function right there. Okay? I'm going to highlight that. Remember, that's always your parent function. You should be able to draw that. Now, what happens to the parent function? Well, you have a -2, so that means it's going to open and reflect downward and get steeper, though, because it's -2, not -1. What's the +1 out here mean? Well, the +1 means it's a translation 1 unit up. So we went out, and then it translated up 1. That's what that figure does. What's a domain and range? Well, the domain is x greater than or equal to 0 because it starts here and goes right. Okay, we're talking about this function here. It goes right, x greater than or equal to 0. What's the range? Y is less than or equal to 1. So it starts here at 1 because it went up, and it's everything is down. Okay, that function, everything's down, so your range is y is less than or equal to 1. Hopefully that answered your questions. Good luck. I'm going to give some notes on homework as well.